Hey everybody! I've got a thing blocking the screen right now. So here, let me, wait, I'm gonna switch back 1 second. 2 seconds, here we go. Okay, good. I just wanna make sure I went full screen on the screen. I don't want the code to get out there. Can everyone hear and see me? We've got 42 people in the game right now. Let me turn on the lights. Lights. There we go. Now we got the lights on. Okay. So now we got lights on. We're good to go. Zach knows the code. Zach, I changed your project grade for you, Zach, to what was it, a 44.7? So go to upgrade it. Down at the bottom, you'll see a scroll wheel down here. You can change the scroll wheel. And it'll upgrade it. So Tracy, go to the Stats1 homepage, and on the Stats1 homepage, you will see where we have like the exams, and then it'll be a sub window where it has like Kahoot, and the Kahoot 2 will be in there. So does everyone see that right there? Tracy, tell me if you find it. You want to be on the Stats1 homepage, and so all this good stuff right there. There we go. Any questions about what is going on, how to do it? So where are you at right now? Where are you at? Exam 2, did you find it? We're just getting ready right now. We're just taking a break and getting ready. We have 78 people watching. We've got 53 in the Kahoot. Did you find it? Oh, wait. Wait, Sophie, don't post it because then people will go right to it. Or click on it real quick, Tracy. Basically, we don't want people to get the code that quickly. There we go. How are we doing on it? So are we using split screens because the Kahoot in this? Use your phone. So you want to use your phone, and then you want to watch this on like your iPad or your computer or things like that. So you want to go. So we don't post the code in the chat. Remember not to post the code. It's just a little bit of juice. So don't post the code in the chat, whatever you do. Wait, don't do the code is. Oh, you guys are too much. You guys are too funny. Awesome. We'll get started here in just a moment. We got 55 people in the game. We got 88 watching live. Good stuff. So we'll go through a lot of questions, and we'll make sure you guys have a good understanding of what to do. So nice job. Thank you, Rue. Everyone helping out. We'll get started here in just a moment. So remember, don't post the code. Marcus, good job, Marcus. We got 52 people in the game. We'll get started here in about 2 minutes. We usually wait about 10 minutes at the start. Can everyone hear and see me pretty well? Is it pretty good with the hearing and seeing? Can everyone see and hear me? So I don't know if I can pin messages. You can't pin messages on YouTube. So everyone can hear and see me pretty well, it looks like. Yeah, YouTube is different. Like Twitch and stuff, I think you might be able to pin messages, but you can't pin messages here. No, I would have a piece of paper out. Yeah, you can still join, Andrew. Andrew, join in the game. Go to the Stats One homepage and go to the code. It's under the Stats One homepage. So go there and have a piece of paper out. Be reviewing. So be ready. So be ready to do it. So let's check this out. You have to. Yep. So Andrew, tell me if you can get in the game. It'll be good to have you in the game here. So I didn't put the code in the chat. Remember to go to the Stats 201 homepage. How's everyone doing? We'll start here in about 1 minute. So we'll start here in about 1 minute. So, Tristan, you're tracking me up in the chat right now. Unfortunately, there's no thing for the code. Here, wait, Tracy, I'll email you it. I'll email you, Tracy, the code. 2 seconds. So Tracy, check your email. That's going to be the easiest way. I think that, yep, there you are. Stat 201, initials, Kahoot code. Okay, so I'm emailing you the code, so you should get it. Okay, there you go. Okay, good. So the code, you should have the code now. And so we'll start here in 1 minute. 1 minute till we start. The nicknames are awesome. It's always fun to see like who's in the lead. So we should see some awesome nicknames here. And I think it's about time for us to get started. Is everyone ready to start? We're on ultra low latency, so there's like a 4-second delay. I'll be reading the questions out loud. Remember, it's not about winning the Kahoot. It's about practicing, learning the material, and being ready. Are there any prizes? Yeah, we'll figure out some prizes for first, second, and third. Let's do this. So there'll be some prizes. Get ready. Join in if you haven't. Get that code ready. Tracy, did you get the email? Did you get it? Didn't get. Tristan, I think you're. Yeah, let me see here. If I have your email, I will email you it right away too, Tristan. And then we'll wait. And don't put your email in the chat. Tristan, I don't have your email, Tristan. But don't put it. Let me see if I can find you on the UTK directory. So 2 seconds here. And then we'll get started here in 1 minute. I want to get everyone in that we can, do a whole bunch of learning, and have a lot of fun. I am not finding you. So sorry, I can't find you. So gmail.chucknorris.com. Like that. Okay, let's do this right here. Here, we'll get started right here. And let's get started on the Kahoot. I'm going to hit the start button. Let's do this Kahoot. Okay, good. Now let me move the block out of the way. Up. Okay, so we have here the probability of getting a multiple choice question correct is going to be 80%. With 5 questions, what is the probability you get at least one wrong? Now, this is a really tough question, so have your sheet of paper out right now. This is a really tough question. What you have to think about is this. We have the probability that you get at least one question wrong, and I'm going to have to move my face around so that way I'm not going to ever block stuff, so I'm going to move it. But think about this. I'm going to give you a huge hint for those working the problem right now or watching the video. When you do this question, the probability of getting at least one wrong is everything but getting them all correct. So the probability of getting at least one wrong is everything but getting them all correct. So that's basically the answer. So I'm going to move my thing so I don't block any answers later. And we'll make this smaller here. So there we are. We'll stay probably right about here for the remainder of the Kahoot. So the probability of this right here is the probability of everything but getting them all correct. So what do? Here, we're solving it right now. Solve it with me. We need to figure out the probability of getting them all correct. That's the probability you get the first correct, and the second correct, and the third correct, and the fourth correct, and the fifth correct. That's the probability you get all 5 correct in a row. What is the probability you get all 5 correct in a row? Well, that would be 0.8 to the 5th power. Now, would you agree with me that you'll either get all the questions right, or you'll get at least one wrong? With that in mind, the answer mathematically, you should see it now. Remember, Everything is 1, but is minus. So everything but getting all 5 answers correct. So what is that mathematically? Everything but getting all 5 answers correct is 1 minus 0.8 to the 5th power. And we'll show this in an example here in a moment. Remember, we're here to learn. So no, we'll see how many people got this. This is a hard one to start. I shouldn't have put like a super duper hard one to start, but it is the complement rule. Oh, we tricked a bunch of people, and let's hope we got the right answer. I'm hoping, because a bunch of people got tricked by this one. A lot of people answered the blue. Oh, because they answered like one question correct. Okay, so let's look at this right here. Let's bring up a sheet of paper, and so we're going to open up a new notebook. It opened up here, and let's just talk about this one briefly here. People are saying in the chat the complement rule, and you are correct. So remember how this works. So let's take a look. Don't worry, you'll come back. You'll come back. What we have right here is the probability of right is equal to 80%. The probability of wrong is equal to 20%. So when you look at this right here, 75th place. When you look at this right here, would you agree if you take 5 questions on a multiple choice test, I don't know how to count. That's a hard thing to do. If you take 5 questions on a multiple choice test, you will either get none of them wrong, or you will get at least one of them wrong. Does everyone agree with this? I want someone to tell us in the chat right now, what is the probability you get none wrong or at least one wrong? So listen to my words carefully. What is the probability you get none wrong on the multiple choice test, or you get at least one wrong on the multiple choice test? Zach, you're awesome. What is the probability you get none wrong or at least one wrong? What is the probability you get 100%? Exactly. Because we would say it must occur that you will get none wrong on the test or at least one wrong on the test. Do you see how I'm adding these two together? This is the addition rule, because we can say you'll either get none wrong or at least one wrong. So then what is the probability you get none wrong? Well, this is what we're going to talk about right here. Getting none wrong, I just want you to think in words, is doing what? Someone say in words, remember, lots of responses. Someone say in words what it means to get none wrong. Someone say in words what it means to get none wrong. What does it mean? Like, I got none wrong. What does that mean? You got what? You got all correct. Exactly. So when you look at this right here, the probability of the one we have highlighted, we'll put it right here, is actually 0.8 to the 5th power. So that's 0.8 to the 5th power. But we said that whatever this is right here has to equal 1. So guess what we can do? We can do some algebra right here. All we need to do is a tiny bit of algebra, and then we get x equals 1. And let me make this as clear as possible. The x we are talking about specifically right here is that area. And so that's the one we're solving for. This is the way to do all of these problems. Does everyone see how this works right here? That we have solved this and we've written out a number line. It's the best way to solve it, I think, and it makes the most sense. Who, and I know I'm blocking the one thing, I wrote a 1 right there. So who thinks, does this make sense to everyone, what I've written right here and how we're solving the problem that we have right here, that you either get none of the questions wrong or you get at least one wrong? That makes sense. I like that right there. So it's important we know how these problems are solved. This is one of the hardest ones. If you know this problem, you probably understand the probability chapter super well. If you don't worry. This is like the top tier hardest problem. So we like to start out with a little bit tricky, and then we're going to get easier. Let's hopefully, we got some easier ones coming up. Let's do this next question. Let's see who's in the lead. It is Brave Shark, and I'm blocking the score. It's a close battle right now between Brave Shark and Inspired Snail. Brave Shark just sounds way cooler. Inspired Snail, Silly Gazelle. Quiz question. Oh my gosh. 2 events that can be easily added together must be what? 2 events that can be easily added together must be what? And I might have to move around my picture during this, it looks like. 2 events that can be easily added together are what? 2 events that can be easily added together are what? 2 events that can be easily added together must be what? And I was just doing it a moment ago. Because remember, you will either get none of the questions wrong or you will get at least one wrong. And there's maybe more than one right answer here. So 2 events that can be easily added together must be what? Oh no! Oh, this scares me. Oh no, 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 no. Okay, so we got a huge thing going on right here. We need to make sure we know the difference between independent, dependent, mutually exclusive, and disjoint, because this is just like a guess right here. So let's make sure we understand what disjoint means. So let's go back to our Word document and make sure we got this. Don't worry, it's all right. We're here to review. That's what we're here for. So let's open up a new Word document and zoom in on this. So what does disjoint mean? I want you to do this with your hands right now. I want you to remember disjoint like this. Disjoint is two circles like this. Does everyone see the disjoint circles? Now they're jointed. Let's draw some disjoint circles. You ready? Disjoint circles means like this. Jointed circles mean like this. And what are we talking about? Well, if we have here event A and event B, what in graphic 1 can event A and event B happen at the same time? In graphic 1, can event A and event B happen at the same time? In graphic 1, can event A and event B happen at the same time? Exactly. No, don't worry, Jeff. That's why we're here to review. This is why the Kahoot is really good. Don't worry. That's why we're here to do it. No, they can't both happen. But look, do you see the joint right here? This is a jointed distribution or jointed probabilities. There's a joint. And which of these look mutually exclusive? Which of these look to exclude each other? Graphic 1 or graphic 2? Which of them look to exclude each other? Like you have two things mutual and they exclude each other. Which of these look to be mutually exclusive? You are right. It is graphic 1 is mutually exclusive. So we have that graphic 1 is mutually exclusive, and that is what disjoint means. Now, here's the craziest thing. If you know, and this is like making an A in the class or making a B in the class, grades you make in a class are disjoint. So you would say making an A depends on making a B. So disjoint events are very, very dependent. So if you make an A, you can't make a B in the same class that semester. So, Andrew, it's so good to have you here. If you make an A, you can't also make a B. So, and thank you for everyone in the chat. It's the chat that makes this. So it's you guys making this stream right now. Hit that like, hit that subscribe if you want. Monetization on the way. But in graphic 1, you can't make an A and also make a B. Can someone give me an example of graphic 2 of events that are not disjoint? What is an event? What are two things that are not disjoint? We're so close. I hit the button and it's like under review in a good way. Good to see you here, Adam. Remember the code's online. I think you can join late. I think you can. You guys are funny. What are two events that would be having a computer, having Allie? Amazing answer, Allie. Great job. Loving ice cream and being smart. That's awesome, right? They're rolling a 6. Now, rolling a 6 and rolling a 3 in one dice roll is disjoint, but in multiple dice rolls is not disjoint because you could roll a 6 and then roll a 3, but in one dice roll, you can't roll a 6 and roll a 3. So it's interesting the ways we can talk about that. Anyway, you can make an A in math and make an A in chemistry. Yep. You can make an A in math and an A in chemistry. That would be an example of this right here of not disjoint events. So that's what disjoint means. Everyone do this also. If you have disjoint events, if you say I made an A in Stat 201, you can't also say I failed Stat 201. Like this is me saying that doesn't happen. Like if I say it rained today, it can't also not rain today. As in like the full weather of the day. Now, not like it didn't rain at a certain point. But imagine someone say, did it rain today? And you say, no, it did not rain today. Then it can't rain today. Those are disjoint. The probability you eat a banana and an orange. So yeah, if you were to say like, I'm going to eat a fruit for lunch, like a fruit, then it would be disjoint. But if you're going to say, I'm going to have fruit for lunch, then they might be jointed and they can both happen. So does everyone understand what disjoint means? If one happens, the other cannot. So the top graphic right here is the perfect example of disjoint. Remember, disjoint is mutually exclusive. And this is not disjoint down here. We'll be doing some independent stuff later and talk what independent means. But when you think about disjoint, if one thing happens, the other thing cannot happen. That is the key for disjoint. Not disjoint means they have an overlap. And Kaylee puts a great thing in the chat. When we have things that can be added together, we use the or word. And you heard me do that just a moment ago when I added things together right here. And I was talking about what's the probability you get 0 wrong or 1 or more wrong. Thank you so much. I get some points in the chat. Zach, you are great. So let's go back, continue the Kahoot. I think we got some review questions in here. We got Brave Shark. Whoa! That's new. Kahoot, dynamic dolphin. Oh my gosh, this is going to be a close Kahoot. So brave shark still in the lead, but dynamic dolphin coming up from the lead. Two events that have no influence on the probability of each other are what? This is a good review question now. Two events that have no influence on the probability of each other are what? They do not influence each other. So think about, this does not influence this. This is what of this? This does not influence this. This does not influence this. This is what of this? Who can tell me? And this is a perfect definition of it. It would be completely this of this. I think you guys will get this. I've got my fingers crossed. I think it'll be great answers. And let's see. Yes, that's some great answers right there. Great work. Don't worry. It's two events that are completely independent, which is a lot of times the null hypothesis, Andrew, in a lot of tests, is like if you're testing, does using a new method of studying work versus the old method, then you'd say it's independent, like it doesn't matter. It doesn't matter which method of studying you pick. Disjoint equals dependent, kind of. Yes. So be careful, Catherine. Great question, Catherine. And let's pull some more review up. Brave Shark has fallen. No, don't stop Brave Shark. I like Brave Shark. I don't know who it is, but they've got my vote. So when you look at disjoint, everything that is disjoint is dependent, but everything that is dependent is not disjoint. Did everyone hear that? I want to see it in the chat. See if you can type that in the chat. Everything that is disjoint is dependent. So that it must, if it's disjoint, it must be dependent. But everything that is dependent is not disjoint. I'm going to explain why here. So everything that's disjoint is dependent. Yep. Everything that is dependent is not, doesn't have to be disjoint. Think about this. Would you say having school depends on it snowing? Does that make sense when I say this? Having school depends on snow. Having school, thank you very much, Adam, right there. Having school, nice job in the chat. Love when you guys type the answers. Having school depends on snow. Does that make sense? Having school depends on snow. Is that a logical statement? Having school depends on snow. I'd say yes. Having school depends on snow. But can we have school and can it snow? Yes. So those events are not disjoint. You can have school and it can snow. Here's the biggest thing I think people run into is we have two topics. We have topic one. Topic one, which we just did, is disjoint. Disjoint means if event A happens, event B cannot also happen. And then we have independent. There is a little bit of overlap, but they are different topics. Independent means if you know A happened, it tells you nothing about B. I'm going to take a coin and flip it right now. You didn't see it. I caught it. Oh, there we go. It's tails. Does that tell you anything about the weather today? So I took a coin, flipped it, and it was tails. Does that coin flip tell you anything about the weather? Does the coin flip tell you anything about the weather? And the answer would be, who knows in the chat? No. So that is what of the weather? The coin flip, the probability of getting tails, and the weather outside today are what of each other? Getting tails on a coin flip and rain outside are completely independent. Now think about the definition of independent. The coin flip tells you nothing about the weather. Now, but think about this. Snow. Does snow tell you anything about the temperature outside? Like if you know it snows, does that tell you anything about the temperature outside? Does it? It does. So snow and temperature would be dependent. So you can think, can it snow and it be freezing? So those would be not disjoint events because it can snow and it's freezing. So you have to remember how to use these. Disjoint, whenever you talk about disjoint, you want to see if two events can happen at the same time. They are disjoint if when A happens, B cannot happen. How about it is over 100 degrees and it is snowing outside? Are those disjoint events? Now someone's going to, I'm waiting for Zach's answer on this. But it's over 100 degrees and snowing outside. Are those disjoint events? Yes, Zach. Yes, those are disjoint because it can't be 100 degrees and snow. There's no way. It wouldn't make it down to Earth. I don't know unless it's like I don't know how it would do it. It's impossible in my mind. Would you say the snow depends on the temperature too? Would you say that in Florida? Snow depends on the temperature, I think we would all say. So those are also dependent events. So make sure to look at what the definition, hot snow. Make sure to look at what each of the definitions are. And I know I was waiting for Zach's answer on that. So we see right here, I want to point out something really big that we have here, that disjoint is the addition rule. So it uses addition, independent is multiply, and then last but not least, you guys have probably seen me do this a lot, this is or, and this is and. So these are the rules right here. We've kind of made just a very quick graphic, which we always make, of the majority of things we look at. Sophie, great answer right there. I like that. But this is, we should know disjoint is when you add things. We use the word or. Disjoint means if one happens, the other can't. And the complement is the minus. Nice job, Kaylee, right there. Complement is minus, and you can just subtract things. You can say A or not A. And if A is 80%, not A is 20%. Great job. Keep asking questions if you got it, and keep putting those comments in. It shows you're following along, doing a great job right there. And so let's see. I think we can just hit Alt-Tab again. So let's here, we'll go up to here. There we go. Okay, we're back on the screen. Let's do this. Who's going to win? Dynamic Dolphin still in the lead, but Wise Lizard, of course Wise Lizard, everyone knows Wise Lizard would be in the lead. Here's the next question. To multiply the probability of A and B, the two events must be, you should know this pretty quickly now. To multiply two events, we've been reviewing it. That's why I like going over these things between the questions, because we get to this question, you should be like, okay, if we're multiplying, we're using the multiplication rule, and two things must be this. To multiply two events, to say like the probability, it snows and I flip a tails today. Like I'm going to flip a coin and the probability it snows. It has a 10% chance of snowing and I flip a coin. And I'm literally giving it away by saying snowing and flipping a coin are two events that are independent. Nice job. We got a lot of right answers on that. So I was kind of giving it away. If you listen to that again, I was like, it snows and I flip a tails. Could you give the full definition of mutually exclusive to add to my graphic? Yeah. And if you want to send me those graphics and stuff, I can post them or whatever you want. Mutually exclusive is the same thing as disjoint. Mutually exclusive just means that if you have event A and event B, think about it, mutual, two events here, there's two things, they're mutual of each other, and they exclude each other. They do not, there's no point at which A and B happen at the same time. So anytime A happens, B does not happen. Anytime B happens, A does not happen. So you have two events, mutual, and they exclude each other when they happen. The complement, great question, Chelsea, right there. The complement is when we subtract an event from one. So we'll add that into our graphic. I think we can just Alt-Tab back to it. Yes. So let's write here, complement is with an E, and sorry for my bad handwriting. Oh, we're on the, there we go. Do we have it now? No, what is going on? There we go. Comp, insert, draw, click pens. There we go. Complement. And it's one minus, and we always say words like not with it. So the complement is when we subtract. I might do that afterwards, Andrew. Great question, Andrew. Yeah, like, I don't think there's any overlap. Yeah, yin and yang would probably be complements of each other. Because if like yin and yang are like good and evil, as long as there's no like middle ground, like, I guess what is it called? Chaotic neutral or something. If there's no like middle ground, then yin and yang would be complements. But for yin and yang to be complements, something must be yin or yang. And for them to be mutually exclusive, then something cannot be yin and something cannot be yang. Does that make sense, Calissa, right there? If something can be yin and yang, then they are not mutually exclusive. So if they're, and then they can be mutually exclusive if there's a chaotic neutral. But if there's a yin and a yang, here, I'll draw it right here. So what we're looking at is, if like, let's look at all things. Like this is everything that can occur. I'm drawing it not as circles this time, but maybe most of the world is yang. And so if we have here yin, and then we have here yang, and this is everything that can occur, like this is the sample space of all things we can occur, then we have here, these would be complements, and they would be mutually exclusive. But now, if we have here chaotic neutral, now everything in here is all complements of each other, because you cannot, we're just adding in chaotic neutral for fun. You can't be yin, and you can't be yang at the same time, and you can't be chaotic neutral. Something is either yang or chaotic neutral or yang. Does that make sense? Most things are yang, some things are chaotic neutral, and the other 30% are yang. But all of these things are mutually exclusive of each other because you can't be three things at the same time. So they're also dependent because if something is yin, that would depend on it being yang. Do these definitions make a little more sense right now? In this example now, they're not complements of each other. The complement of yang would be not yang, which would be things that are chaotic neutral or yin. So if something has a probability of yang, we'll put probability of YA equal to 30%, because we're just saying that's 30% of that grid, then the probability of not yang is 70%. So the complement is just 1 minus the probability of the event. So the probability of not yang, and I'm just making up these probabilities, don't worry, ask any questions you have, we're here to help. So these events right now are mutually exclusive, disjoint, same thing, and all three of them are complements of each other. Like, if you were to say the complement of yang is the two other things, that's correct. You can't say yang and yin are complements. You can if you do this, though. If there's only two things, then yin and yang are complements of each other. Great questions. We've done a lot of probability work right here. So excellent, excellent work on learning it. Dynamic dolphin and wise lizard. Swift gorilla. That's awesome. I love all the names. Great job. Here's the next question. Read the following sentence as a sentence. Ooh, I like this one a lot. Good probability stuff. You're right. Let me get out of the way of the answers. So think about the words I just put in there. If you're doing this and you're watching the video, rewind and look at the cheat sheet we just made. What is the plus word? What is the star word? What is the plus word? What is the star word? Start scanning the questions for what the plus means as a word and what the star means as a word. Start scanning because I see some ors and ands. So you just have to figure out which order they go in. When you see plus, you should think or, and when you see star, you should think and the answer is... Great job. Amazing work. Awesome. Stay in here. We're reviewing. But does everyone understand this? Please ask questions at any point. Brian, how'd you find that? What's going on? 41st, Zach's moving up in the world. It's because people are leaving Zach. I'm just kidding with Zach. But all that good stuff right here. I'm going to try to hang out here in the corner. Oh, you ran out of time? No. Hit refresh on it, and then that'll put you on the shortest delay. So how long are you guys getting for the question? Like 20, 30 seconds? Hit refresh on it. Brave Shark is in 40th. So make sure to refresh it, and it should have you on the shortest delay. The shortest delay is only about 4 or 5 seconds or so. Not long enough. I think I put longer things in for some of them. So maybe just refresh the page and also hit the live button down below. Make sure you're watching live. Does everyone see at the bottom of the screen there should be like a live button? So, and make sure to listen to when I read it. So, no, I'm so sorry. I should have made this longer. I know 30 seconds I should remember is a bad idea on Kahoots on the internet because then you guys might only get like 15. So here we go. You guys ready for the next one? Let's do this. Remember, we will review any of them. So the big thing is not winning. It's understanding the concepts. Here we go for the next one. A gross jelly bean has a 25% probability. If you eat 3 jelly beans, what's the probability they're all good? Okay, so we're doing, once again, the probability of all jelly beans being good. 120 seconds. We're excellent on this. Okay, so first thing we need to think about is we have the probability that a jelly bean is gross. So what's the probability that a jelly bean is good? I want to see it in the chat. What is the probability that a jelly bean is good? Does anyone know what the probability that one jelly bean tastes good? Any ideas? 75%. You are right, Abby. Nice job. So then what's the probability that you eat a good jelly bean, and then you eat a good jelly bean again, and you eat a good jelly bean again? So what's the probability that you eat 3 jelly beans in a row that are good? What is the probability that you eat 3 jelly beans in a row that are good? Any ideas how we do that? You can put it in the chat if you want. So you'll be helping out. Think, listen to my words because we've been reviewing this. The first is good, and then the second is good, and then the third is good. The first is good, and the second is good, and the third is good. They're getting it. Oh, be careful. I think they're getting it. Zach. Yep. And as long as I have the right answer in here, and I hope, because I'm always afraid I put a wrong answer in when I like update and change questions. But the first is good, and the second is good, and the third is good. How am I able to multiply the jelly beans together? Like when I say I eat the first, and then the second, and then the third, why am I able to multiply those probabilities together? Why can I multiply them and say, like, what's the probability of getting 3 good jelly beans in a row? Like, why can I multiply those together? Why does that work? They're independent, Campbell. Nice job. Because you said and. You're right. And is the magic word. And then the rule for that is independent. And look at all those right answers right there. Amazing work. 120 seconds is really good. I should just put them all to 120. You are right. They are independent, and that's what we have going on right there. So I think we thoroughly explained that one. Please ask questions. How did you find that? I don't understand. Great questions to ask. And so will the test, there's a lot of multiple choice, and we'll be sending out, I believe later tonight or the Saturday, I'll be sending out practice tests, which you can take to understand what the format will be like. I need some M&Ms. How did you know it wasn't disjoint? Because, and remember, disjoint is only used when we talk about event A and event B cannot happen at the same time, so they wouldn't be disjoint because you could get a good jelly bean and a good jelly bean again. Like the first could be good, the second could be good, so those are not disjoint events. But the first jelly bean and the second jelly bean do not care about each other. There's not partial credit, but we are doing the big curve. So be doing all of your practice tests, and you print out the formula and you get a scratch sheet of paper. I believe we are going to release the answers for the test after it's done. Can you work this one? Yeah, let's work it. And has anyone watched, because it's a lesser watched video, which is all right. Has anyone watched the video I put out with the formula sheet? Because we go over that a lot. The practice test should be sent out at latest tomorrow morning. Sorry for the delay on that. We're just making sure everything is perfect, and then we're sending it out. So we will send that out probably at the latest tomorrow morning. So when we think about eating 3 good jelly beans in a row, we have right here the probability of bad jelly bean is equal to 25%, one of those gross jelly beans, and the probability of good jelly bean is equal to 75 because the jelly bean is either bad or good. We're treating those as complements. And so we have here the probability the first is good, and then the probability the second is good, and then the probability the third jelly bean is good. And right here we just get 0.75 times 0.75 times 0.75. And that has it. That is the formula right there to get it. Sorry if my handwriting looks a little crazy. Yep. Thank you, Abby, right there. I'm glad that video is really helpful. A few people wanted me to make it, so check out the video. We subtracted, yeah, so for this one, you could do the probability there's at least one bad jelly bean, but whenever you do an at least one problem, it's everything but all good jelly beans, if this was the example. So we will either have all good jelly beans, like this, or you could take this and simply subtract it from 1, because would you agree with me, either all the jelly beans are good, or there's at least one bad one. Does that make sense right there, Chelsea? So you either have what I've underlined now, and I'll highlight it, is the first jelly bean is good, the second jelly bean is good, and the third jelly bean is good, and either all 3 of your jelly beans will taste good, or there'll be at least one bad one. I just got why multiply. We multiply because we're saying you eat the first, and then the second, and then the third, and you can multiply them because they're independent of each other. So yeah, if you do that right there, so Hey It's Jay says, so what you did right here is instead of finding they're all good, you found at least one is bad. So, and I'll put that, Abby, if you can help put the video in the chat, or we'll put it at the end. It's one of the most recent videos, Zach. I go through the whole formula sheet for the test, and I explain what everything's on it. So I think it's a really helpful video because it lets you know exactly how to read your formula sheet. So, and it's a review video too. So does that make sense right there? Hey, it's Jay. Does that make sense with what this solves? So what I have highlighted right here is 0.75 to the third power, which is every jelly bean is good. And if you do 1 minus that, you get there's at least one bad jelly bean. So great job with all the answers in the chat. Excellent, excellent, excellent work. Okay, let's hop back in to the Kahoot. Who's leading the way now? Nice job. Yeah, it's a lot of work, and you guys are doing excellent. Dynamic Dolphin. Wise Lizard's coming. That's, of course, Wise Lizard. Which of the following is a rule of probability? Which of the following is a rule? QQ, straight enough? No. Which of the following is a rule of probability? Which of the following? Thank you so much, Abby. Abby posting the link there for the video. And you guys are excellent. Excellent, excellent work. I think everyone knows that we no longer will use QQ, straight enough, no outliers. So I'm kind of giving away the answer right there. But probabilities have to be contained between 0 and 1, and all probabilities must add up to 1. So that just says the probability of an event must be greater than or equal to 0, and the probability must be less than or equal to 1. QQ straight enough, no outliers, plot doesn't thicken are the rules for regression. So QQ straight enough, no outliers, plot doesn't thicken are the rules for regression. So nice job. That's a pretty easy one, so I'm going to continue on to the next one. And please, if you're like, oh no, I'm so sorry, Rue. Here we go with the next one right here. Which of the following is not a rule of probability? I guess I put in 2 of these. So now we get into a little bit more difficult one. Now slow down. Watch out, because there's a rule in here that you might think is a rule, but be careful. It's not called that. So there's one that might trick you, but it's not that. I said pretty much all of them so far today. The addition rule is where we use the or and things must be disjoint. We just covered that probabilities must be between 0 and 1. All the probabilities must add up to 1. We don't call anything the subtraction rule. We call that the complement. So there is a thing, I think I might show you at the end, and then I might get Kahoot Pro after this to let you guys actually like review your stuff, which is really cool, but you have to have Kahoot Pro. So maybe I'll ask UT and they'll give us Kahoot Pro, which would be really cool. But I think this does it for probability. So we have here all the probability stuff we've been doing, and really great work. Please ask questions if you have it. Here we go with the next one right here. A researcher decides to take 5-mile segments of roads and sample each 1-mile segment within. Now be very careful. They're taking a whole bunch at once. They're taking a whole bunch of roads at once and sampling 5-mile segments. So they're going to go out and take a 5-mile segment and do a census on that. So they're taking 5-mile segments, like here's a 5-mile segment, and they do a census on it. Then they take another random 5-mile segment, and they do a census on it. These are all random 5-mile segments, which is like a group of roads randomly put together, and then they do a census on it. And the answer is... I see some stratified still in there. Okay, so this is a big thing, and we would cover this a lot. So let's make sure we know the difference between stratified and cluster. Big stuff right here. You ready? Okay. Oh no, Rue, I'm so sorry. And I know I should put 60 seconds on these. I'm so sorry. Here we go. You ready? What is the difference between cluster, and I think I'm just going to write it today. What is the difference between a cluster sample and a stratified sample? So whenever we do, and these will be used throughout, cluster. Okay, when you do a cluster sample, things are put randomly into groups. Randomly pick those groups. Perform a census on the groups picked. Okay, so this is a big thing with cluster sampling. We should know how it's done. We, in my class, talk a lot about M&Ms. Like if you take a bag of M&Ms and do a cluster sample on it, does everyone see that we are assuming the M&Ms in the bag have been what? What is the first step? What do you assume about those M&Ms in that bag that just like, well, these are just blank M&Ms. Like what do you assume with clusters? And then they're just randomly put together. And so be careful because we're going to change the example here in a moment with stratified, but they're just randomly put together. It's just like you're not telling any key difference between the M&Ms. You're just choosing random M&M bags. The bag is the cluster. So we're going to randomly pick bags of M&Ms. So we're assuming the M&Ms have been randomly put into bags. We're going to randomly pick the bags, and then we're going to eat the whole bag to test it. We're going to be like, okay, we have to eat every M&M because every M&M is a sample, and the bag itself is the cluster. People get confused on stratified because it's also a group. So stratified, you must first, and this is the big thing, acknowledge a difference. There we go. And that's, I think, did I ever write something else on it? That's really it right there, is you sample the difference randomly by its percentage. So think about this. What are differences between M&Ms that you would sample on? Like, I always bring these to class when we do it. What differences would you sample M&Ms on? Like, what's a key difference between M&Ms? Everyone else says color. Color is true. Color is true. Type. I like type. Everyone else says, because we think about color first, but it's like the answer every semester. Because I'm always like, because I always bring like peanut butter and regular nuts, and nuts is a big difference. So and the thing is color may be something important to the factory, like maybe plain versus peanut. Exactly. This is stratifying. So imagine Volkswagen wants to check out the quality of their cars. If Volkswagen said we want to collect SUVs, we want to collect info on SUVs and luxury cars, and what are the other kind of cars are called? Trucks. I don't know. So they said we want to collect all these differences. Are they talking about clustering or stratifying? If they said we want to collect differences, we want to collect SUVs and trucks and town cars and stuff like that. So would that be are they trying to cluster or stratify? They are stratifying. They are very much stratifying because they're acknowledging a difference right there. They're saying, okay, we have trucks, we have SUVs, we have town cars, so it would be stratifying. Now be careful, but I want us to think if they were talking about a cluster, that would mean that the trucks are randomly put in the truck group. No, trucks are a difference because when we stratify, trucks are different than SUVs, so the vehicle type is how we're stratifying. We're stratifying based on type of vehicle, but if you were to cluster sample, you might say, okay, let's collect, we're going to go in and do a quality check on every vehicle made in the factory this hour. So you're going to pick a random hour, and that would be a cluster because you're going to do a quality check on every vehicle made that hour. You have to make sure that that hour is like a random hour, and it's not like, oh, the machines are shutting down and they're not working properly. But if you were to take every car, we're not going to talk about any differences here, but every car that was made that hour, every vehicle that was made that hour at the factory and took info on it, that would be a cluster. Does everyone see that we would hope the vehicles made that hour are just randomly put into that group? So that's another example. I have my classic examples, but I'm trying to come up with new ones. But if you were to take samples of cars and you were to acknowledge differences between the type of cars, you'd be stratifying and you'd maybe take 20 SUVs, 10 trucks, and 40 town cars. If you were to cluster sample, you would say, okay, let's sample every vehicle that was made this hour and take information on it. Because then once again, you're doing a census. So stratify is type, kind of. Remember, yeah, pretty much. I think that's decent. I'll say that sounds good. I don't want to say yes because I'm like thinking of a way it's not that. But stratified really is based on type. Like when you think about this, just use the type thing again with like, and having this written down, I think some of the best stuff. Think about donuts. How would you stratify donuts? 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 Any ideas on stratifying donuts? I just want donuts. How would you stratify donuts? By the different flavors, filled or not filled. Exactly. You're acknowledging differences right here. How do you cluster sample donuts? How do you cluster sample donuts? How would you cluster sample donuts? How would you cluster sample donuts? What would be a cluster of donuts? Any ideas on clusters of donuts? What's it? Think about it. Yep, a dozen. There you go, right there. A dozen is, and remember, so we don't want to. The store could be a cluster. It's so hard because stores can be like acknowledging differences, and then there's one of your questions that talks about a gas station. It says cluster sample at location. Now remember, we don't, because if we only took the originals and we took all of them, and that's what you have to do, you generally, it's making me hungry too with the donuts. You generally want to say like, we're going to go and sample boxes of donuts. Those donut boxes are clusters. So generally, if you're talking about company, as soon as you bring company into it, you're probably stratifying. Like if you want to look at the quality of donut, you might be talking about, and so great answers right there. Just thinking about this kind of helps because if you're like, okay, company versus company, anytime you can say versus, like this versus this, and it seems like there'd be differences, then you're stratifying. But if you're just saying box of donuts 1 versus box of donuts 2, can anyone tell me why there'd be any inherent differences between box of donuts 1 and box of donuts 2? No, you can't. Because what is the assumption between the boxes is that they're put randomly into these groups. But if you were to say Krispy Kreme versus Dunkin', people will be like, oh, Krispy Kreme's got the glazed and Dunkin's, I think, more baked donuts type for cluster. So for cluster, you never acknowledge any difference for it for cluster. Saying versus helps, I think, a lot too. So like when you say like Coke versus Pepsi, is that cluster or stratified? I'm giving it away. Like Coke versus Pepsi is, if you were to take samples on that, would you cluster or stratified? Coke versus Pepsi. So Coke versus Pepsi would be strata. Yep. because you're acknowledging a difference. But what if I say if I say 6-pack 1 versus 6-pack 2? Now I'm using verses. I'm trying to trick you. But what if I say 6-pack 1 versus 6-pack 2 of Coca-Cola? Well, okay, don't pretend you say Coca-Cola. But 6-pack 1 versus 6-pack 2, even though I'm using verses, there's no inherent difference. It's like, well, I guess these are randomly put together cans, and the 6-pack is a cluster. So both of them are groups. I think that's what confuses people. But this versus this is what we're talking about when we do stratified, and you have to think of an inherent difference. I'm trying to think of the other big ones I use. You could think of a pizza. If each slice is a sample, the pizza would be the cluster. And then how could we stratify differences with pizza? I'm making everyone hungry now. How could we stratify differences among pizzas? There's many ways you could do this one. So both are groups, but if the same thing, but yeah, if you can't acknowledge a difference, the whole goal of clustering is to take a whole bunch of one at once, to take a whole bunch of samples. So when you think about why would you take a box of donuts versus individual donuts, it's to speed up the process. And you take random and toppings. Yep, that's an answer. You would take random boxes of donuts. Why wouldn't you just sample each individual M&M at the factory one by one? Well, that takes a long time. So you would take a cluster sample, and you could take a bag of M&Ms and do a sample from that bag. Instead of going to the machines and taking random M&Ms out of the machine, you just assume that the M&Ms are put randomly into bags, and then you could look at the quality of your M&Ms by doing clusters, and you'd eat them all. Does that make sense? So I think clustering is often used to just speed up the process of taking a whole bunch of samples at one time, where stratified, big question here. Stratified could probably be used to help us deal with what kind of bias. What kind of bias would probably help us if we might have had this issue? Stratifying would definitely help us deal with it. Stratifying probably helps us deal with this. If we have what sort of issue? It's like if we don't get enough of something, we can ensure we get enough of it. Undercoverage, Ren, nice answer. Stratified definitely helps us deal with things like undercoverage. And convenience, convenience would be bad. No, we don't want to make it too convenient. Convenient is when you go out and get the first few of something. So great review on that. Let's do the next one, 1 million points. I've got the points turned off for the moment. Nice job. So we should, I don't know who's all here. But we'll try to do some sort of, so group versus group is still cluster. It's just, I wouldn't say group versus group. I would just say, let's go out and collect bags of M&Ms. Let's go out and collect boxes of donuts. Let's go out and collect classrooms of students. But so when we do this right here, I'm so sorry. So everyone leaves the video. So, but type versus type. Yeah, when you can acknowledge a difference with the verses, that's when it's stratified. And I think I'll have some key examples coming up right here. Great job, Princess, right there. So when you can acknowledge a difference, when it's like county roads versus city roads, hint, hint for coming up later, that's stratifying because you're acknowledging a difference. I think we'll have them coming up, Alexandria. Tell me if I miss any here in a moment, but I think they're all throughout the review. So we'll see them. We'll see if you get them, and then I'll review them. Great question. Okay, who's leading? Daring Panther. Oh my gosh. Here we go. A researcher selects their sample based on the percentage of highway, country, and city roads. So, and if I miss something, just tell me. So I think you guys will get this in the background. So if I have a bag of M&Ms, a box of M&Ms, and a car, that is some ridiculously large clusters. Those are, now you want, if you're really doing cluster sampling, Tracy, right there with that example, you would need random bags of M&Ms to do it with that, or random boxes of M&Ms, or random carfuls of M&Ms. Like someone randomly filled cars with M&Ms, and you could take each of those cars as a cluster. You'd randomly select them. And this was a review question right here, so I didn't focus on it too much, but it's stratified because I was kind of giving it away. But if you had 1,000 cars that were randomly filled with M&Ms, then each of those cars would be a cluster because it's just random car filled with M&Ms. So, and then in this one right here, as Zach points out, we would acknowledge the difference because do you think city roads are different from highway roads or different from country roads? So in this example on the screen right now, we would have differences between the city roads, country roads. Could you say city versus highway versus country? Then that sounds like difference. But in Tracy's examples previously, it'd be car 1 full of M&Ms versus car 2 full of M&Ms. I mean, there's no real difference there. It's just this versus this. I mean, but not in a way that we really think there's a difference. Zach, you're awesome. Here we go. Who's leading now? Oh my gosh, Daring Panther, Agent Elephant. Ooh, I think Agent Elephant's gonna win. I got my bets on Agent Elephant right now. So you guys are awesome in the chat. A researcher selects the first 20 roads next to their house. Ooh, you should know this one. Someone was asking about this one just a moment ago. They just walk out their door and they say, I don't got time for this. They say, research, who needs research? Let's just take the first 20 roads. Let's do this. Let me call up my friends and ask them for what they think about roads. Let me post a survey on the internet and ask people what they think about roads. I love the chat. You guys are awesome in the chat. I think we're really lucky because everyone got convenience. I think everyone knows what convenience sampling is. Convenience sampling is when you have access to things really easily. You post it on Facebook. You get the first things you see. You walk to campus. We are. I think everyone knows what I really, really like because, we've had talks like, I think they posted it on Canvas. This will be posted on YouTube. Yep. Go take that Spanish exam, Justin. Good stuff there. This will be posted. I think everyone knows that we know how to control our YouTube chat because I think, posted something on Canvas saying like, make sure to be respectful and definitely be respectful in here. Like we'll say something, but we can, people's things can be removed. I think I've gotten much better control of this chat and you guys are awesome. No, Kara, we got you. We're still reviewing. We were just doing sampling and this can still be watched after, but so good to have you here, Kara. So, Huan, good to have you here too. Aw. Rocky Top is the real home. I'm still around here at Rocky Top. So we'll be good to have everyone back. You guys are awesome. Okay, so we'll continue on right here. Please ask any question if you haven't. We're just having some fun in the chat today. Ooh, soaring seal. Why is it always like a soaring? Ooh, they're tied. Agent Elephant, you got to keep it up. You got to come back. Here we go. A researcher selects every fifth road. Now, technically, this would be every fifth road from a random starting point. So they're going to pick a random starting point, and they're going to select every fifth road. It's like they've kind of got a system in place. Hint, hint, hint. But they're going to select every fifth road. So they're going to, does it tell you that you're first? They're going to select every fifth road from a randomly selected starting point. And so that wouldn't make it multi-stage. You just have to take a random starting point in this and then select every kth element. So you're hearing me give the definition of it right now, and I'll go to the workpad here in a moment. Everyone kind of knows that one. Great stuff. Not kind of knows it. You really know it. So let's go over here, and let's put it on the screen. And what do we have? We have systematic. Systematic is pick a random starting point, or generate a random starting point. Select every kth. We can do better than that. There we go. Observation from here. So you just simply pick a random starting point and you select every kth observation. Remember, we're doing all the notes as we do this. Everyone did really great. I spend more time on the ones people get wrong. So you guys know this one. Excellent, excellent work. Let's continue on here. Daring Panther, Agent. See, I told you Agent Elephant's it's gonna happen. Quiz. A researcher lists all the rows and then randomizes the order and then selects the first 50. Now there's a tricky thing in here. They're selecting the first 50, but they randomize the order of the roads. Roads is what we use in data a lot of times. So they randomized all the roads and then they select the first 50. So is that convenience? If they randomize all the roads and then they select the first 50. Is that really convenience? The answer is no. It's actually a simple random sample. So I think that confuses a lot of people. Oh, we didn't confuse that too many people. It would totally be a simple random sample because, let's bring up our notes here again. We can just Alt-Tab over to it. And simple random sample. Everything is sample. Systematic sample. Okay, cool. Now what we do is everything is given a random number. Observations are chosen randomly. I knew there was only one O in that. I did it and I knew it. So we have right here, if you select the first 50, then randomize. So it wouldn't be convenience. We did this one as a trick question a long time ago. Sorry for a trick question, but a lot of people thought this was convenience. Oh, you're right. Kalissa's right. If you select the first 50 and then randomize it, it's convenience. It's order offered. Kalissa, you are so right. Nice answer right there. If you select the first 50 and then randomize that, that would be convenience. But if you randomize all the roads and then select the first 50 are actually what now? Who knows in the chat? It's one of my favorite words we talk about all the times. If you were to randomize all of them and then select the first 50, we can give Kalissa 1 point. She's the only person to get the 1 point today. Kalissa, you get 1 point right there. Zach has bestowed it. It's random. Oh my gosh. Did someone say random? What? Oh my gosh. Someone said random. That's just, it's random time. We had to do it at least once today. Okay. So there, you'll take it. It's like she had 1 point. So, okay, we'll continue on right here. Agent Elephant, ooh, Daring Panther, doing such a great job right there. Daring Panther, excellent work. So we'll continue on. He was number one. I split the 1 point between us. The researcher takes too many city roads in their sample. I'm so happy that you guys like it, Abby. If you take too many city roads in your sample, what have you done? What kind of bias do you have? And we'll talk about all these biases afterwards. If you take too many city roads, what kind of bias do you have? If you take too many city roads, what kind of bias do you have? Any ideas? Too many of something would mean you have too few of something else. There's the hint, Zach. Do it quick. It means you have too few of something else. Too many of something, too few of something else means you've undercovered it. So people put response bias. I wonder why. So response bias, I don't know if these roads could really give us response bias, but don't worry, we're here to learn. Response bias is when the question itself or the person gives a response that is biased. One of our favorite ways of doing a response bias question is, you guys ready for this? I want to see it in the chat. So many of you are probably not 21. Is it fair right now that you could go to war, you could buy a house, you could get married, you could own animals, you could do all these things, but you can't buy a beer? Is that fair? Is that fair? Zach says absolutely. Is that fair that you could do all these things, but you can't buy a beer right now? If you're 20, you could go to war, you could buy a house. Ali says no. So Zach might think it is. So Chelsea says no also. So what we have right there, or even, have they changed the smoking age? So with, Tracy says beer is gross. So you can't drink anything though. No wine, no Captain Morgan's, no nothing. So what you have right here is that is response bias. Is it 21 now? I don't believe it is. Unless I guess I don't pay enough attention to laws. So, but the way the question should be asked should be, is it really? Oh my gosh. I'm a boomer. That's crazy. So I need to look all this up. Really? Wow. That is craziness. Wow. That's interesting. Well, but if you have too many, how can you get undercoverage? Yes. So what would happen if we got too many city roads? What would happen to the highway roads? I got an okay boomer from Ali. What would happen to the highway roads if we had too many city roads? If we had too many city roads, what would happen? We would what the highway roads? We'd get not enough. Does that make sense right there? So if you get too much of something, you get too little of something else. So if you get overcoverage leads to undercoverage. You overcover city roads, you undercover highway roads. So you'd undercover because you get too much of something in your sample. So that's why we could stratify. Abby, great question. Convenience bias we talked about. It's convenience sampling. It's when you take the easiest things you have access to. Non-response bias is when pretty much people hang up the phone. It's probably the best example of that. You call up people and you're like, hi, I want to talk to you about this survey. And they But a lot of times it's maybe a question that they're not interested in. Non-response bias can occur if you call people for political surveys and they don't have a political opinion. So that way the people who don't respond differ than the ones who do. Let's add these in. Zach, great idea. Let's write these in here. So let's go over here. And we are only missing, no, those are the main ones. There's multi-stage. Let me write multi-stage on here. Multi-stage. We'll just putting together. So you can do like, you could take boxes of glazed versus boxes of filled donuts. Boxes of glazed versus boxes of filled donuts would be the boxes would be the cluster, and the types of donuts would be the stratifying. You could take every fifth box of glazed and every fifth box of filled, and then you would have a systematic stratified cluster. The fifth box, we don't do many multi-stages. It can be, but they can get confusing. So usually it's like a one more advanced question, but you just have to, it's literally just putting them together in different ways. So we sometimes do a multi-stage thing on there, but you can just put them together in different ways. It's like each of these is a Lego, and you can put it together with another Lego. So there's many different things you could do for multi-stages. So it's really hard to say them all, because there's like, you could put this with this and this with this. So really great question right there. Thank you for the question. And now we have response bias. Response bias is when the question of the person taking the question adds some bias to the response. So once again, when someone says, is it fair that the drinking age is 21, yet you can go to war? That's a biased question. So will we know what we got wrong in the practice? I think so. I think I'll have to look. So I'll update you on that, but I think we can show you what you got wrong. I want it to be that way. And it's kind of to just orient you to a respondents exam if people haven't taken it. So convenience. Can I spell it right today? Nope. How do you spell convenience? There we go. Close enough. Close enough that the spell check gets it. Taking the first... what do I mean by a very easy way? Convenience, nice job, Tracy, right there. Convenience would be like posting it on Facebook. That's not a really good way of doing a survey. So you have convenience bias there because you're likely to reach your friends. They're the first people you have access to. So posting it on Facebook is a convenience bias. And then we have... So non-response bias. So non-response bias, so if the reacher went out to specifically take more city roads than others, that's response bias. No, if they take too many city roads, we would have undercoverage. Great question right there, Ren. So this would be undercoverage. So certain... So if we were to have no highway roads or no city roads, we would undercover them. And it's probably because we got too many of something else. So undercoverage happens when we get too much or too little of a certain group in our survey. Like, it's literally the idea of getting too little. But I think sometimes people don't realize that it happens because you get too much of something else. Like, imagine if you wanted to talk to students and you only talk to seniors. Well, then you've talked to too many seniors, so you've undercovered all the other classes. Does that make sense right there? Like, if you say, I want to talk to students and I only talk to seniors, well, then you overcovered seniors, so that leads to an undercoverage of every other class. So the overcoverage of one group undercovers the other groups. Non-response bias is if you go outside to Pres walkway and you hold up a sign saying, I'm doing a sign on political surveys, and everyone's like, I don't want to talk to them about politics. So the people who don't talk to you are exhibiting non-response bias. Where can we find the practice exam that we'll be posting that, I believe, at the latest tomorrow morning, Alexandria. So that'll be posted at the latest tomorrow morning. So stay tuned. There'll be lots of announcements, and we do have the formula sheet posted. Abby was checking that out. So the formula sheet, I have it on YouTube right now, and I'll be posting it, and I'll be sending out a lot of key announcements. Thank you for everyone for being here. All these great questions and this great review. Let's continue on. Do we have more biases in here? Here we go. The researcher is unable to get information from certain roads. Ooh, they're unable to get information. They can't get information on them. They can't get information on these roads. Which of these definitions sounds like it now? So it's not the question they're asking. It's not that they didn't try. Hey, what's up, Connor? If you got my email me back, and we'll try to figure out a time. Connor might be helping out with some stat stuff, and I'm very excited about that. So I love when people just drop in and say, I really do. It's like, yes, awesome. So I think people will get this one now. Yes, they know it. Connor, look at that. That's awesome. I like seeing all those great responses right there. So they can't get a response from those roads. They go out and try to collect data. And so think about this. If you can't get data on a road, might that road differ than the other roads you can get data on? So remember, if you can't get data on a road, might that road, because non-response, when the people who respond differ in their views than those who do not respond. So if we can't get data on a certain road, maybe it's because we can't drive to it. Like that road's in really bad condition. So this would be, nice job, made top 5. Ooh, let's see. Might guess who you are. Oh wait, didn't change around. It'd be different and some would probably be different. So that would be a non-response bias. Question 16. The list of roads the researcher has access to sample. The list of roads the researcher has access to sample. You guys crack me up in the chat. I love the chat. The list of roads the researcher has access to sample. What would this be? The population is every person or thing they're interested in sampling. The parameter of interest is what they want to understand. The sample is everything they take a data on. And the sample frame is everything they have access to sample. So the sample frame would be everything they have access to sample. Great job right there. Once again, the population is all people or things. Let me write these down for you real quick, and I think that'll cover a lot more of this. So population. All people or things we want to understand. Let me put this on a new page. There we go. So the population parameter. This is what we want to understand. There we go. And then scroll up a little bit here. The sample. Actually, I usually go to sample frame next. Sorry, written. All people or things we have access to take data on. And then the sample is all people or things we collect data on. Does this make sense right here? Can we please go over this? Does this make sense right here, Abby? I hope this helps out right here. The population, good. And keep asking questions. Could you post this Word document somewhere after this week? Yeah, let me post it. So I'll figure out some way. Oh, I'll post it to the Stat2Own webpage. I'll post it under the review site. That way everyone can see it, and I'll just be like, review from Kahoot. So Kahoot, if I can say it properly. Great questions, and thank you everyone for being here. Keep interacting. I love seeing the people in the chat asking the questions. And just know these flashcards are key for all this. It really helps. And let's continue on. Here we go. The road that the researcher samples. I love the Zach quotes. Zach should make a list of quotes for my class. I spoke in cursive for a moment. That's what happened. So the sample is what you collected. Yeah, the sample is what you actually get data on. Like the roads you actually get data on. Like the sample is what you collect. So think about that. Like here's my sample. It's like the roads you actually took information on. So if you get what I'm pointing out on this one right here, the sample is what you actually have data on. So that's awesome. Oh no, I want to see 100%. So close. I'd love to see those quotes from your high school physics teacher. So great job. I think we know that one. Here we go, the next one. The roads the researcher wants to understand. So these are the roads they want to understand. Like they're saying, we need to understand the roads in Knoxville. We need to understand the roads in Knoxville, like all roads in Knoxville. So they're like, I want to understand all roads in Knoxville. Now they're not saying I want to understand like the quality of the roads or how many potholes there are per mile, but they want to understand all the roads in Knoxville. They're saying that is my what? All the roads in Knoxville, that's what I want to understand. That would be my what? All the roads in Knoxville. I'm glad it's boosting it. I want to see 100%. Oh, no. I think because the wants to understand is in there because it's not what they want to understand about the roads. It's just that it's not what they want to understand. Sorry if I've confused everybody with the definitions. We'll hop back to that sheet. So the parameter is what we want to understand about the population. So the population is the things we want to understand. They should all be people or things. I think I put people or things. So does everyone understand that the roads in Knoxville is the population. We want to understand the roads in Knoxville. But the parameter, coming up later, would be things like how many potholes per mile there are, which is just a characteristic. It's just like the parameter is what you want to understand about the population. So you can call it the population parameter, you can call it the parameter of interest, but the population is the thing we want to understand. Oh no, I'm so sorry, Calissa and Zach and everyone. But the population is the things we want to understand, and the parameter is what we want to understand about them. Does that all make sense to everybody right there? Please ask questions if you have it. I know I tricked some people on that one. I wasn't trying to trick you, but always try to think of your own thing. Like, be like, okay, if I want to take samples of UT students, I probably want to understand UT students. So the population would be UT students, and then I want to ask them, what do they think about this Kahoot? On a 1 to 10 scale. So the parameter would be, what do you think students think of Kahoots? So our parameters like questions about, parameters are basically what you want to understand. Chelsea, great answer right there. So I could get negative 0 points. So still at where you're at. Parameters are what we want to understand about the population. It's questions we ask them, and then it's the big understanding. So it's called like a parameter of interest. What is our best guess of a parameter? What is our best guess for, we got to do it. Why not? If you're in the Kahoot right now, for 1,000,000 points, what is the best guess of the parameter? This is outside of what I've written. What is the best guess of the parameter? The best guess of the parameter is what? The best guess of the parameter is what? Who knows what your best guess of your parameter is? Anyone know for 1,000,000 points? Anyone know what the best guess of the parameter is for 1,000,000 points? Close, Carrie, you're close. I know where you're going with that. What is the best guess of the parameter? Yes, Molly. Molly got it. Nice job, Molly. It is the statistic. And I'll also take Rachel's answer of the sample mean, and everyone's saying... So I'm gonna give it to Molly and Rachel. They get the points right there. And it would be the statistic. The statistic is your best guess of the parameter. Because remember, population parameters, sample statistics. So what do? We go out and we collect a sample. This is what we do in statistics. And from that sample, we make a what? From that sample, we make a statistic. And that statistic gives us a best guess of the parameter for the population. It kind of goes up this way. Like you get a sample, which creates a statistic, and the statistic estimates the parameter, which is what we want to understand about the population. So every time, remember we say SSPP, because SS stands for sample statistics, and PP stands for population parameters. Yeah, definitely. Yeah, you earned a mod too. Definitely. Ren, you are right. Thank you so much. And everyone, who else do we have? We need a mod. Calissa, you've been here. Chelsea. And if I don't mod you, you can email me on your UTK account and be like, hey, Brian, I want to be a mod on the channel. So, just be like, hey, Brian, I want to be a mod, because I can unmod people. The worst thing a mod could do is they could start, timing people out who don't deserve timing out. Other than that, they really can't do anything. And thank you, everyone, so much, because we haven't had... I don't think anyone's going to steal the code now, but I mean, we still don't want that. We haven't had any problems, really, with... the YouTube chat where people have said crazy things, but we just monetized the channel. I think I said that earlier. I like that, Zach. We just monetized the channel, and so who knows what's going to happen once the monetization comes through, as long as it does. But it said, we're going to look at your top videos and everything, so I'm like, I'm fine. They're going to be like, it's just an education channel. Okay, so let's do this. The researcher is collecting the average amount of potholes per mile. This is what they want to understand. So the researcher is collecting the average amount of potholes per mile. It's what they want to understand. What do we have going right here? The researcher collects the average amount of potholes per mile. It's what they want to understand. Any ideas? Any ideas? And I'm giving some tests at 4 to some people, so I'll probably be ending right at 3:45. Sorry if I'm going a little quick towards the end here. We've had a lot of good fun and a lot of good review. We're not done yet. But I think everyone knows that this is the parameter of interest from our review and writing down the notes. Yes, I like seeing those answers. Great job right here. That is some amazing answers. Great job. The parameter is what they want to understand. Here we go. Probability of making a shot is 0.30. What is this? Complement? This is, who knows how to do the complement. We had this question earlier. I'm trying to remember who asked it, but if you asked the complement question, I think by now you should know it. Yes. Connor, I love it. So who knows how to do the complement right here? Who knows how to do the complement? Does anyone know? We have the probability of making a shot is 0.3. What's its complement? See in the chat right there. So what is its complement? Complement is 1 minus. So all you do, there you go, Abby, nice answers in the chat. And I like that because people watch these videos and so don't worry if you put the answer in the chat because maybe it's a wrong answer, who knows? But people watch this and the exam 2 will come out Sunday night and it'll be available on Monday and Tuesday online. And remember, so the probability of making a shot is 0.30, the probability of not making a shot is 0.70. And great job everyone right there, 1 minus P. Great work in the chat. Next, we continue on. Daring Panther in the lead. That was a little bit of an easier one. The law of averages is a fallacy. The truth is... wait. I got to get out of the way here. The truth is what? Don't worry, I wasn't blocking the right answer. So the law of averages says if you're at a slot machine, eventually you'll start winning if you're losing. Like if you lose a whole bunch, eventually you'll start winning. So what is the truth? It's the law of large numbers. And I know this is a lot to read. But if heads occurs too much, tails is more likely. That's the law of averages. And then we have 2 other things on here. So I think people are getting it. Who got it? Yes. This is just the law of large numbers. This is probability. So we were doing this even yesterday in 474, that we have independent trials, and in the long run, we'll see the true probability. So if you just take a quick note right here, that the law of averages is a fallacy. The law of averages states that if we flip heads, tails is more likely because a coin's 50-50. That's a fallacy. And past events do not influence independent trials. Each one is its own independent trial, yep. And so the law of large numbers states that we'll see the truth in the long run, but past events do not influence independent trials. And so that's key. And what can you do with independent trials to figure out what's the probability of flipping heads 2 times in a row? These are independent trials. What's the probability of getting heads and heads? Can anyone do that? This is a good kind of very simple review problem. How do you find the probability of flipping heads and then flipping heads again? You multiply, you're right, and it'd be 0.5 times 0.5. What's the probability of flipping heads 10 times in a row? Can anyone tell me in the chat, what is the probability of flipping heads 10 times in a row? Who can tell me what's the probability of flipping heads 10 times in a row? Like you flip heads, and you flip heads, and you flip heads. What is the probability of flipping heads 10 times in a row or flipping tails 10 times in a row? What is the probability of flipping heads 10 times in a row or flipping tails 10 times in a row? What's the probability of heads 10 times in a row or tails 10 times in a row? I don't see the answer to that one yet. So what's the probability of flipping heads 10 times in a row or flipping tails 10 times in a row? Close, and Jacob got it right there. Jacob is right. Jacob and Sophie, yes. Listen to the keywords. Flipping heads 10 times in a row is 0.5 to the 10th power, or plus tails 10 times in a row is 0.5 to the 10th power, which I believe is just 0.5 to the 9th power. It might just be, but does that make sense right there? It's very unlikely. So you could say, what's the probability I get head 10 times in a row or tails 10 times in a row? And the or is the addition. Because can you flip a coin, just like, let's say I flipped a coin 10 times, can I get heads 10 times and in that same thing get tails 10 times? Can I do that? This is a review now. Can I flip it and get heads 10 times, also get tails 10 times in those 10 flips? Like, not that I did it twice, flipped it 10 times twice, but you are correct. That means those things are what? Getting heads 10 times and getting tails 10 times, which both can't happen, are both what events of each other. Those are what events of each other. And it's why we're using the plus right there. Mutually exclusive disjoint. You are correct. So you know the rules of probability pretty well. That means you can add them because you can't get heads 10 times and tails 10 times. Great job. Excellent, excellent work. Let's continue on to the next question here. I'm blocking the scores. Daring Panther. When I get back into my office one of these days, we'll have to give. If you ever come to my office and you're like, Brian, I won that Kahoot, well, please have it like in your email, like even if it's like a year from now. Come by and I'll probably, if I have a Starbucks gift card, I'll give it to you. And if I don't, I'll just give you like $5 out of my wallet. I'll be like, I don't have a Starbucks gift card. Here's $5. But yeah, unless everyone starts to come to my office and be like, Brian, I won the Kahoot. We know that UT is 20% freshmen. We sample 200 students, 30 report being freshmen. What is P hat? So we want to find P hat. This is a notation thing. P hat is the sample proportion. It has a hat over it. It's P with a hat over it. So what is the sample proportion? The sample proportion is X over N. And so we have to say there were 30 people who reported being freshmen out of 200. So what is the sample proportion? 30 over 200. Who knows the answer? So remember, if you're watching this, you can review it. But you should know symbols like P hat are the sample proportion. And it's how many we have in our sample that are out of the total. And it's 0.15. That's a pretty easy one right there. Next we get, We know UT is 20% freshmen. What is N? I'm just gonna sit back. Just gonna move my chair up closer and sit back. I think everyone knows what N is right here. But I want to point out some other stuff, and I might be giving away other questions. When we say we know UT is 20% freshmen, that is P. When we say we know UT is 20% freshmen, that is P, because that is the true proportion. We sampled 200 students, that is N, that is our sample size. 30 of them, that is X. X is the amount in the sample that report that they conform to the group, so we can get p hat from that, and I think everyone knows what N is. Oh no, are you guys messing with me? You guys know what N is. It's the sample size. N is the sample size right there. So we'll continue on, and if you have questions, ask. I'm gonna have to hop to the next thing here soon. Daring Lizard, still leading the way. Daring Panther, Wise Lizard. So we have right here, we know UT is 20% freshman. What is P? Please take these notes as we're doing this right here. P is the true proportion. So you have to tell me what the true proportion is. It's something we know. P hat is the sample proportion, which always comes from a sample size. So you have to make sure you know that P is the true proportion. P hat is the sample proportion. Another example would be Volkswagen makes 20% trucks. We take a sample of cars on a parking lot and find out that 30% of the cars that are Volkswagen are trucks. So in our sample, 30% of Volkswagens were trucks, but Volkswagen reports as the truth that 20% of their cars. So 20% what Volkswagen reports is going to be P, but if 30% in a parking lot are trucks, then that would be P hat, because that's a sample. Does everyone understand that? Let me do it a little bit smoother of an example. We know from DMV statistics that 20% of the cars on the road are trucks, or 20% of vehicles on the road are trucks. We go to a random parking lot and sample every car in that parking lot, every vehicle in that parking lot, and 30%. What kind of sampling method did we use? We go to a random parking lot and sample every vehicle in that parking lot. What kind of sampling method did we use? Does anyone know? We went to a random parking lot and sampled every vehicle in that parking lot. What kind of sampling method was that? It's a review question. Cluster, you got it right. Nice job, Hugh. So we got it right. So exactly right. So awesome stuff. So we will continue on with the review. I tricked you. You're like, he's going to do a probability one. UT is 20% juniors. From 80 students, 30 are juniors. Find the mean of the sampling distribution. Ooh, this sounds tricky. This sounds tricky. So we know UT is 20% juniors. What is the mean of the sampling distribution? So if you went out and sampled UT students, what percent of people would you expect to be juniors? If UT is 20% juniors, what percent of students would you expect to be juniors in your sample? You know UT is 20% juniors. What percent of juniors would you expect in your sample? And the answer is, if you know UT is 20% juniors. Now here's the important formulas right here. And I've got a lot of videos going over the reviews. So we have some really important. So we have mu p hat equals p, and standard deviation p hat equals p times q over n square root. So all this right here, this is the one we just did. We say we know UT is 20% junior. So what do we expect the mean of the distribution of the sample proportion to be? And we'd expect it to be p. So since we know p, the problem states for us that this is 20%, well then we know that the mean for the distribution of the sample proportion is 20%. Now get ready, because you're probably going to be solving this next. So now, here's a hint for a later question. Probably might be next. Just kind of, and then I think it was 80. So that would be the standard deviation. Does everyone see how I found the standard deviation right here? I plugged in p times q over n square root. And you will be given these formulas that should have an equal sign between it. But that is the formula for the standard deviation. From this, you would draw the sampling distribution. And you'd go right here, you'd put your mean, and then you'd go up and down the standard deviations on this curve. Does that make sense to everybody right here, how we use this and what it means? We did a lot of review this yesterday, really great reviews. And I do want to say this, do remember that although I'm posting 3-hour videos on Tuesday and Thursdays, I do the class twice. So you get to hear it. I wouldn't watch it twice if I was me. If I was me, I wouldn't watch it twice. But because I know some people were like, wait a minute, we have to watch a 3-hour video. It's just me doing the class twice. So I don't just do it one time. I kind of do it twice, so it's different times people can watch it, and so it's recorded and everything, but it's twice up there and 2 different versions of it. But anyone, if you're watching this now, you're free to join in on that class. So do we have people from other sections in here right now? Anyone? So from other sections? No? Is it only mine? So timestamps, yes, I know. I need to go in and do some timestamps, and thank you. Chelsea, so good to have you. Yeah, and if you put timestamps, there we go. Blake, awesome. Fish and everyone. So yeah, so you guys can watch the videos at any time. You can join live, Princess and everyone. So you can join live and watch the videos. They're 3 hours, but class is still 75 minutes. It's still 75 minutes of class covering all the topics. Yep, you can, and if you're in the second class, you can still come to the first. I just didn't want to be like, I'm only going to broadcast class once. I'm going to do it twice. That way people can have different times for it. So Juan, good to have you. And you can watch them, you can interact, and then the videos are posted afterwards for you to watch and still, get information from. So you're not meant to watch the whole 3 hours because I do the class twice. So don't be like, oh, it's a 3-hour video. No. It's 75 minutes with me taking like a 15-minute break and then 75 minutes. And then I might talk afterwards or something. But you can fast forward, you can put it at 1.5 speed, all that good stuff. No, I never said that, Zach. I never said that. And you can ask the people online right here. Yeah, no, Calissa, good to hear that. And you can ask everyone. We have fun in the chat. So, Juan, let's make you a mod right here. There you go. So, and if you have a different name, just email me and I'll add you in. If you're like, hey, Brian, I really want to be a mod, we'll make you a mod for the channel. You're from Higgins. Here we go. Let's add you as a mod right here. So good to have everyone here. Remember, this is posted afterwards. Let's do this. Here's the next one. UT is 20% juniors from 80 students. 30 are juniors. Find the standard deviation. Now, we just did this. Remember, you need to find P times Q over N square root. Oh, you're welcome, Alexandria. You guys are awesome. I really appreciate it. It's really nice to help you guys learn. I like it. You guys know this is my thing. It's like I teach. I like it. So I think I'm lucky because, oh, thank you, Ren. So it's fun. I like all the conversation online because it's, this one's just P times Q over N square root. P is 0.2, Q is 0.8, N is 80. Make sure you know your notation. Oh, we're almost done. The immortal. So lols. So is that like a lols cow? So, thank you so much, Chelsea. Having a good time. That is awesome. Oh, thank you so much. And so we should have this one right here. Nice job. Remember, we just did this formula. We'll tab back to that screen, or we won't tab back to that screen. We'll tab back to the screen over here. Here we go. With my horrible handwriting, it's simply P times Q over N square root. The problem states that 20% of people are juniors, so the complement is 80. The problem states that the sample size is 80. P times Q over N square root. Oh, we're making you. Thank you. See, there's the mods right there. Mods, you are awesome. And you know what, Princess, you have earned the mod. You are now a mod. So, especially you type a formula, you earn it. Now everyone's gonna type formulas. So, make you a mod right there. Like I said, I don't think anything truly bad can happen with mods. It's just someone could start you can't mod other mods. So, we can be as long as I've never really had problems. One person was trying to remove, if someone comes in, especially if we have the Immortal here and they want to say, hey, they're more than welcome to. So we're happy to have you, Immortal. Glad you dropped by. We get random people, especially if we hit that monetization, we might get a lot more random people. So we're always glad to have you. What is a mod? Here, I'll make you a mod. If we were to have problems, if people were to come in here and say things they shouldn't say, they'd be moderated. So, if you're a mod, we'll make sure if you're saying things you shouldn't say, I can unmod you and then we can remove it. So, we want, a good, healthy community because YouTube kind of moderates that. And then if people say things they shouldn't say, we can remove it. So we have had rare instances where people it wasn't really bad, but they said 1 or 2 things. We're like, okay, bye. Because we can just remove them immediately, block them on the channel. We're almost done here. Here we go. Time to finish up the Kahoot. From the sampling distribution of the sample proportion, what is the third condition? Condition 1, random. Condition 2, 10%. Now, this is the sampling distribution of the sample proportion. I know, right? So email me and I'll add you. Oh, no, we'll add Fish right here. You've been here the whole time. Pause. You got it. There's my New York accent. Pause. So what we do, condition 1, random. Condition 2, 10%. And then we pause. And the third condition here is success failure. Now I'm going to go over this briefly right here. Let's talk about it. So it's success failure. Great job. Large enough n is for the next chapter. Large enough n is for the next chapter. And oh my gosh, look at all those pages everywhere. So let's talk about this right here. Okay, how do we know if it's random? If the random means we take a random sample. So that's pretty easy. Condition 1 is random. If you're going to go out and talk to UT students, you should do it randomly. That's the first condition. Condition 2 is 10%. Let's say UT has 30,000 students in it. How would we know if UT has 30,000 students? I'm just guesstimating. If UT has 30,000 students, how would we know we passed the 10% condition? How would we know we passed the 10% condition? If UT has 30,000 students, how would we know we passed the 10% condition? Yes, and so you're right. So we would take a sample of less than what? If we have less than 3,000, exactly, Zach, great answer. And boom, everyone's saying it. So less than 3,000. So remember, less than 3,000 because the population is 30,000. So we have to sample less than 3,000. You can just move the decimal place over 1. Like if Volkswagen makes 2.1, or let's say 2 million cars a year, our sample of Volkswagen cars would need to be less than what if we meet the 10% condition? Our sample, if Volkswagen makes 2 million cars, then our sample needs to be less than how many cars? 200,000. Correct. Does everyone see that we'd sample less than 10% of the population? That's the condition right here. Great job. Great answers. Now, the third condition is success failure. So what is the third condition right here? When you think about this, let's say we're sampling cars and we take a sample of 2,000 cars. In the sample of 2,000 cars, 150 of them have faulty engines. Now, what's interesting is if we do a confidence interval, then this right here is the answer for the confidence interval, and it's complement. Only when we do confidence intervals, though, with success failure. But if we say we know from Volkswagen that the true proportion of cars that have problems is equal to 10%, the true proportion is equal to 10%, then what would NP be? Yep, and Campbell's doing it. What would NP be right here? Who can solve for NP in this problem and who can solve for NQ? NP would be what? And NQ would be what? And are they both greater than or equal to 10? NP is equal to this. NQ is equal to this. And remember, Q is just 1 minus P. So Q is 0.90. Oops. I'm thinking about the next answer to come. So we have here, so who can get NP and NQ? NP would be 200. And then down here, this would be 1,800. What do you notice that NP and NQ add up to? Because what you're saying here is you're saying if 10% of the cars have engine problems, I'd expect 200 out of the 2,000 have engine problems. If 10% of the cars have engine problems, I'd expect 90 to not have engine problems, which is 1,800 cars I'd expect to not have engine problems. Does this make sense here? This is the success failure condition. So, yep, and that's the whole sample size right there. So you're saying I'd expect this many. What are these conditions used for? These are used to do the sampling distribution of the sample proportion. And then if you do it with p hat, it's the confidence interval for the sample proportion, or confidence interval for the true proportion made from the sample proportion. Let me repeat that. The one we just did right here, right now, is for the sampling distribution of the sample proportion, which was the problem we just did a moment ago with p hat, right here, p times q over n square root. This is the sampling distribution of the sample proportion. And then if you do it with p hat, you're doing confidence intervals. They're both called the success failure condition. The other version of it would simply be when you use p hat. But in this instance, we would not know p, because why would we make a confidence interval of the truth if we don't know the truth? And this question would now read, we want to figure out what percent of cars have engine problems. We say take a sample of 2,000, 150 have engine problems, make a confidence interval to estimate the true proportion that have engine problems. So now in p hat is equal to, NP hat is equal to 150, and NQ hat is equal to 1,850. And this represents the number in the sample that had engine problems and the number in the sample that did not have engine problems. So you can see from the numbers that if 150 had engine problems, 1,850 did not have engine problems. This is where, and I should mention it because I don't know how many problems I have on this, this is where, after we pass the conditions, we'd do P hat plus or minus Z star, P hat, Q hat, look how similar it is to last one, over N square root. And this would build a confidence interval. Key stuff right here, hint, hint, hints for the test, is that this is the margin of error. Everything right there is the margin of error for the confidence interval. If this confidence interval theoretically came out to be 10 to 20%, what would the margin of error be? Now, I don't think that's the answer, but if this confidence interval came out to be 10 to 20%, theoretically, and maybe, you know what I should do? I should just solve it. Let's go down here. We'll go over here. I should just solve it and figure out what it is. So we're going to need the calculator on the screen. So confidence interval and sampling distribution, they have the same three conditions for the confidence interval and the sampling distribution of the sample proportion. It's just how we use them slightly different. It's still called the same three. Random, 10%, and success failure. Success failure for confidence intervals is NP hat, NQ hat. Success failure for sampling distribution is NP, NQ. It's a great question there, Rachel. So this is what you can do on the TI. Yep. So if I had a TI with me right now, I could do it. And it'd be 5% in my random example right there, 5%, because it'd be 15% plus or minus 5%. The actual answer for this is going to be, let me do it here. Got just enough time to do this. And I'll top off very soon after this. So this is, not fun numbers. I think that is that. And it's a 95% confidence roll. So there's the confidence interval right there. Does everyone see what I've done? And this right here is the margin of error. So you can solve this right here to get the exact margin of error, but that is the plus or minus on the interval. And so that'll solve it for you. It's a 95% confidence interval. We would give you the Z-score. Do not memorize them. No, don't worry. Great question there, Fish. Do not memorize them. Do not memorize them. What if I were to tell you, and I like these sorts of questions because I think they're nice, simple, and quick. What if I were to tell you, let's go grab a steak dinner, and the dinner costs between $20 to $30. What is the margin of error of that interval? $20 to $30. Oh, no. So what is the margin of error of the interval from 20 to 30? Be careful, Zach. Be careful. Remember, margin of error is just half the interval. So don't worry. Great answers. But this is why we review, and this is why I do these ones right here, because this could be written. Try writing it out like this. Remember, if it's a margin of error, you can do this. So that's how we do it with the margin of error. Does that sound... No, don't worry. Don't worry. Great job, Campbell and everyone, and Zach. Don't worry. It's practice. Because the margin of error is the plus or minus, and it's half the length of the interval. Does that make sense to everybody right there? It's half the length of the interval. Always try to keep a quick example in your head like, my textbook will cost between $70 to $90. $70 to $90 would be a margin of error of what? $70 to $90 has a margin of error of what? $70 to $90 has a margin of error of what? We'll have just enough time off to do the last bit quick here. It would be... There we go. So you guys are getting it. That's awesome. Let's hop back in here. We'll finish up the Kahoot with just enough time. Who's going to win? We got Daring Panther. Oh, Mountain. I don't know how to say that. We got 3 more questions, so I'll have to go a little quick. For the sampling distribution sample mean, what is the third condition? This will not be on this test, but it's just on here to help us review for future stuff. Please close your ears if you don't want. But this is for the third test. It's new material, but it's not on this test. Condition 1 is random. Condition 2 is less than 10%. And then when it's the mean, it'll be large enough n. So I might go a little quicker at the end because I'm doing some other, I've got a meeting at 4. So it'll be large enough n, and this is new material for test 3. This is new material for test 3, so I've kind of given that one away. That's for test 3. I think I might have, so if this is all, oh good, oh my gosh. Whew, it's a randomization problem. What % of the time did you get heads? Okay, so did you get 2 heads? So you have to look at these numbers right here. I'm going to solve it with you. And if you look at these numbers, 0 through 4 represents heads. So if you notice, we got heads, heads, heads. We got heads here. Nope. We got, oh wait, look, heads, heads. In this trial, we got 2 heads. That's one trial. This trial, we got 3 heads. Does everyone see I'm converting these to heads because 0 through 4 is heads? So we got heads here and heads here. So that's 3 heads. Nope. So in this trial, we got 1 heads, 2 heads. Good. And this one, we got all heads. That's all heads. That's all heads. So the answer is 2 out of 5. Ooh, that was a tricky one. So if you were solving it as I was solving it, I think it's 2 out of 5 trials. Did I make a mistake? It should be 40%. Oh no. So I think it's 2 out of 5 trials because it's exactly 2 heads. Oh no, everyone's putting in different answers. I think it's 40%. I didn't count the 4. Oh no, wait. Did I put a wrong answer in this? Did I get it wrong? Oh no. So here's, oh my gosh, I did. I got it wrong. Oh no. Oh no. Great job. You're right. There were 3 heads right there. So, oh, that's what Connor was saying. He was saying there's 3. Dun, dun, dun. I don't know how to do this stuff. Great job. I was going too quickly. Go slowly. Double check your work right underneath it. Fail. F for respect. So, I know. Oh no, Zach. No. Everyone's losing respect for me. We will, as long as it's not, so Huan, great question. As long as it's not, as long as it's not a major problem, we're just, show the full room, show everything you can. We're only going to really, don't cheat, but we're going to make sure, like, we only really go after low-hanging fruit, like things that look very obvious. Oh, thank you so much, Jay. Everyone makes mistakes. It's too easy, especially with these problems. I swear, if I took every test you guys took, I'd probably make like 97s or 98s. I was coding this morning and I made a few mistakes. It happens. You can know how to. It's like when you're adding up change or something, you'd be like, wait a minute, I didn't add this properly. So, do what? You have to do like a quick room show. You'll see we'll send out the practice test. So you just like turn your camera around and you just like show the room you're in to make sure you're not like posting notes or there's people, hanging out. But we'll post examples of it. So it's pretty easy to do. You just kind of like move your computer around. It's like a 360 view. But we'll have the practice test up. Does that sound good for everyone there? I got the last question, then I'm gonna have to jump into the other thing. Last question. Your other exam? Oh, it might have been different. This one, what % of the time did you get 2 tails? Wait, is this a different number set? Okay, good. I made this question so long ago. Okay, here's my redemption. So did you get 2 tails? Oh, it's 2 tails. So here's 1 tails. There's 3 tails in this set. What do I see here? 1 tails, 2 tails. And here's 2 tails. Okay, I think I know the answer. I think this Kahoot, I really have good faith in this Kahoot. I've looked over the test, and it's a lot of multiple choices, a lot of true, false. Does that mean W or more? No, it just means 2 tails, just 2 exactly. I should have written exactly 2. Kahoot doesn't let you put that many words into these, so I was very short on my words, and I had to make the random number sets for these. So I have no idea what that means. I got rickrolled just a day or 2 ago. So I'm surprised rickrolling is still around. So, you're shocked the things that still exist. So it's 2 out of 5. My redemption. The code is, you get to see the code now. The code is, here's the code. I should just remove that there's the code. Good job. Go ahead and enter in the code. Crash our Kahoot. Oh no, it's over. So we got Wise Lizard right here. We got Excited Griffin, and they can ask questions in the chat. They can, who is the winner? Oh, is it going to be Daring Panther? I got rickrolled again. It's like 2 days in a row I got rickrolled. So we got Mountain in the background. Thank you guys so much for being here. You won. Awesome. We'll try to get a prize to you, Catherine. So stay in contact, email me, and we'll try to get you a prize. All that good stuff right here. Rick Roller came in at the end. Could you put P-hat and P&N such difference on the Word doc too? Yeah, let's do that real quick right here. Let's hop over to the Word doc. Or not. let's not hop over to the Word doc. Wait, where's our Word doc with all the words? So, let's see. I'll do this really quick right here. Insert, equation, this. If you can tell, I've already done p hat before on here. There we go. So p hat is equal to the sample proportion found by, and then this is found by x over n. That is p hat. And then p is equal to the true proportion, and then n, lowercase n, is sample size. So an x is equal to number of successful trials, and q slash, well, we need to put in here then. Put it after this. There we go. Q slash q hat. So q slash q hat, the complement. Whoa, why did it do that? There we go. Nope. Really? I'm fighting it. Oh wait, no, we can do. So. Well, the complement of p, or I think everyone should know what that is. So pretty good stuff right there. And I guess p is technically lowercase. I think that's got it. I'm gonna hop into the next thing right here. Text now, Zoom. Zoom, good comment right there. And they can say those things. I have no idea, as long as they don't say anything too crazy. Awesome. Thank you for the review. Thank you for everyone hopping in here at the end. Text now, Zoom, and everyone. Good seeing everyone. It is now end of class time, or end of review. So we got this. We'll end here with our classic ending, because you know I love it. It brings back memories. I need to talk to Jason. So text now, Zoom. I'm going to go to my office. So just hang on a second. I'll be right back.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!